Hi students, let's take a look at this. X plus 9 less than 0. Now, this is just saying whatever x is, when I add a 9 to it, the result should be less than 0. Now, let's try a few guesses. So, let's try some values for x. If x is equal to minus 11, then x plus 9 becomes minus 11 plus 9, which is equal to minus 2. Yes, it is less than 0 and this inequality is satisfied. If x is equal to minus 10, then x plus 9 becomes minus 10 plus 9, which is minus 1. And yes, it is less than 0, once again satisfying the inequality. Now let's try x is equal to minus 9. Then x plus 9 becomes minus 9 plus 9, which is equal to 0. And 0 is not less than 0. So this inequality is now not satisfied. What about when x takes the value minus 8? Once again, the inequality is not satisfied because the result is 1. Minus 8 plus 9 is 1 and 1 is not less than 0. So the inequality remains unsatisfied. So can we figure out the exact boundary where things start to work? Yes, it's between minus 9 and minus 10. Okay, so things start to work somewhere starting from a minus 9.1, or it could even be even more precisely minus 9.00001. No, it's definitely larger than, or rather, I'm sorry, definitely smaller than minus 9. Okay, it is definitely less than minus 9, and it is not minus 9 because minus 9 plus 9 gives us 0 and 0 is not less than 0. So it is everything smaller than minus 9. Everything less than minus 9, and this is what is actually plotted on this number line. You can see that empty circle which indicates that minus 9 is included. I'm sorry, once again, which says that minus 9 is excluded, and then it moves towards minus infinity. Okay, so all values of x less than minus 9, less than minus 9, excluding minus 9, and right up to minus infinity satisfies the inequality. Now let's take this. X plus 9 less than or equal to 0. This just means whatever value I plug in for x, when I add 9 to it, the result should be at most 0. It can be less than 0 or it can be exactly 0, but not more. So let's try out a few values and see what works and what doesn't. So we are checking the inequality x plus 9 is less than or equal to 0. So let's assign the value minus 11 to x. X plus 9 would become minus 11 plus 9, which is equal to minus 2. Yes, it is less than 0. It satisfies the inequality. X plus 9 is less than or equal to 0. Now let's assign x the value of minus 10. So x plus 9 becomes minus 10 plus 9, which becomes minus 1. And yes, it is less than 0 and satisfies the inequality. What happens if x is assigned the value of minus 9? Well, then x plus 9 becomes minus 9 plus 9, which is equal to 0. And yes, it satisfies the inequality because the inequality says x plus 9 are less than or equal to 0. not just a less than 0, but a less than or equal to 0. What happens when we assign the value minus 8 to x? Well then, for the first time we see that we get a result minus 8 plus 9 which is equal to 1, which is not less than or equal to 0. So when we assign minus 8 to the value of x, we get the result 1, which is neither less than 0 nor equal to 0. Okay. So now can we figure out the exact boundary where things start to work? Yes, it is any value of x that is minus 9 or less than minus 9. Note minus 9 is also included, and that is why we have a filled in circle or a shaded circle, and then we have an arrow pointing towards minus infinity, indicating that all values of x, including minus 9 and less than minus 9, will satisfy the inequality x plus 9 is less than or equal to 0. And here we have both the inequalities plotted on the number line, x plus 9 less than 0 with the empty circle indicating that minus 9 is not a solution of x, but everything less than minus 9 is. And here we have x plus 9 less than or equal to 0 plotted on the number line with the filled in circle or the shaded circle indicating that x can take values less than minus 9 and also including minus 9. Let's take this equation x plus 9 equal to 0. This means that when we add 9 to x, the result should be exactly 0. In other words, we are looking for just one number that balances the equation perfectly. Let's try plugging in a few values and see which one makes it true. Checking values for x plus 9 is equal to 0. If x is equal to minus 11, then x plus 9 becomes minus 11 plus 9, which is equal to minus 2, and that's not equal to 0. So this equation will be false if we assign the value minus 11 to x. What about assigning x the value of minus 10? Well, then we get minus 10 plus 9, which is equal to minus 1. And again, that's not equal to 0. So again, the equation is not satisfied. What happens when we assign x the value of minus 9? Then x plus 9 becomes minus 9 plus 9, which is equal to 0. Yes, this satisfies the equation x plus 9 equal to 0. And what happens when we assign x the value of minus 8? Then x plus 9 becomes minus 8 plus 9, which is equal to 1, and 1 is not equal to 0, and this equation remains unsatisfied. So the equation x plus 9 is equal to 0 is only true for one value when x is equal to minus 9. That's the only solution. All the other values fail to satisfy the equation. And we have plotted this on the number line. We can clearly see a shaded circle or a filled in circle right above minus 9 because that's the only solution for this equation. Okay, it's only when x takes this value of minus 9 is the equation satisfied. Now we have these two inequalities and this one equation plotted on the number line so that you can compare all three of them. We can see that in the case of inequalities, x can take a range of values. In the case of x plus 9 is less than 0, it takes a range of values less than minus 9, but not minus 9 itself. And in the case of x plus 9 less than 0, x takes a range of value including minus 9 and less than minus 9 up till minus infinity. just as in the case of this one, which also goes to minus infinity. In the case of an equation x plus 9 is equal to 0, we have only one value. X takes only one value, namely minus 9. I hope this is clear to you now, students. Thank you very much.